Alright, okay, let me make sure I have all of these going. So, you wanted to know why certain things happen in this question the way they do. I don't know which part. Actually, let me go look. We can see here. How did you answer the past exam? I'm not sure why the answer is what it is. I also know the answer to this. So, you look at the K, right? Remember, K is equal to products over reactants. Products over reactants. So you have concentration of bah. Concentration of bah. EDTA. EDTA is a common solvent in organic chemistry and biochemistry. So you will see it. You'll see it a lot in the future if you plan on a career in science. But you'll have bah, and that's not how you spell it. But I don't think I really care. It's not how everything should be in there. But who cares? And then you have BA in the denominator. E D T A in the numerator. Now, this is a huge number, and their concentrations are small. Yeah, they're small. So, if I check the effective concentration, EDTA 50, that's, we do 30, what do you call it? We have 30, okay, I don't need a bracket. It has a concentration of 0.3 molar. Sorry, not 30 molar. 0.3 molar, and this has a 0.3 molar and 50. So 50 milliliters of a solution of EDTA that is. So you have 30 times 50 equals 100. So first we do our dilution, which 0.3 times 5 is, where's my calculator? That's crazy, my calculator is in fact gone. So we will do 0.3 times 15. Thank you. 15 divided by 100. So that's 0.15. Actually, I really should have seen that coming. This is, you're doubling the concentration, so you're doubling the volume, so you're halving the concentration. If you remember, molarity is equal to moles over volume, so since you double it, you have the concentration. So that gives us 0.5 molar EDTA, and then that gives us 0.1 molar. 0.1 molar. What is that called? 0.1 molar barium. Right? Now, RK is huge. That is a very big number. So that goes to show you, it's pretty much, if you were to put this in a fraction form, this concentration here would have to be 7.1 times 10 to the 7th power larger than this concentration, multiply this, larger than that. That is kind of insane. So, that means you have so much space in solution. It's so favored. It's so products favored that you pretty much only get products. So, when you do your conversion, you take, how many, so it's 1 mole to 1 mole. Yeah, 1 to 1. So how much EDTA do we have? We have 0.5. So we get 0.1 molar barium. Yeah, we get 0.1 molar barium EDTA. This is equal to 0.1. And why is it 0.1? Because, well, it's so products favored that it really wants to all turn into, what do you call that? Barium EDTA. It really all wants to turn into barium EDTA. And that's fair enough, because look at how big, that's a huge number in comparison to the other K constants we're working with. With water, we're looking at 1 times 10 to the 14th. That's tiny. in comparison. Now, we go here. Solution is diluted. After equilibrium is reestablished, the number of barium moles is the number of barium moles present in the solution greater than, less than, or equal to the number of barium moles present in the original solution before it was diluted. And the answer to this is yes. The number of barium moles are equal to the number of barium moles present in the original solution. And remember, it's not asking concentration, it's asking moles. Shoot. And why is that? Well, if you see in the thing, it shows you 1/10. If you see, normally this will show you 1/10. You know the answer, so this shows you 1/10, 1/10, 1/10. Well, that 1/10 is the same for everyone. And since the ratio changes the same amount for everybody, it's going to still be the same concentration. It's not going to be the same concentration, but it's going to be the same concentration ratio. And it's also, you're not taking away moles, or you're changing the concentration. You're reducing the concentration by dilution, but you're not changing the amount of moles, because in the you have a more concentrated solution. The moles never change. The volume is the only thing that changes when you do dilution. So I assume that part isn't so hard. The part that was annoying was, remember, this is a gigantic number for K, and some Ks are gigantic. This is such a gigantic number for K that it goes to completion. That's why. It's so big, it just continues and goes the whole way through. But that is all I think I see for this question, so I hope that helped, and it's time for me to end this.